In this video we're going to talk about the equations of a state. The equations of a state is any equation which relates pressure, temperature and a specific volume, which are, for instance, the properties that describe a system. And you know, for instance, ideal gas. And there are other two very important, which are, for instance, real gas with compressibility factor. We're going to discuss that in a later video. And the real equations of the state for real gases. So let's start with ideal gas. So we can refer to an ideal gas when the temperature of whatever we're talking about is above the critical temperature. That's a gas. And we usually start with this ideal gas equation. P times V, V being the specific volume, equals RT. And R is the ideal gas constant, and it's defined for each substance. But how do we define this? Isn't it a constant? Well, of course it is. For example, R is 8.314 kilojoule per kilomole Kelvin. Now, since we're always trying to state that the specific volume is given in cubic meters per kilogram, well, we have to change this kilogram, this kilomole here, to kilograms. And in order to do so, what we do is that, for instance, we are going to take the R for oxygen, and we're going to divide the 8.314 over the molar mass of oxygen, which is 32 in this case, and we get 0.2598 kilojoule per kilogram Kelvin. We can do the same for the rest of the compounds or mixture or whatever. All of these are reported in a table. So R in this case is going to be very specific for a substance. Although it started from the same constant, it's only the constant over the molar mass. So once again, we're relating pressure, specific volume, and temperature, and it is going to be given by a constant R. So we can write this as R equals P V over T. Since the R is exactly the same, we can say that the pressure 1, volume 1 over temperature 1 equals a pressure 2, specific volume 2 over temperature 2, because we're equating the R's, right? And this is true, yes, for closed systems, which means that there is no mass entering, no mass going outwards, so the volume is not changing due to the mass. And it's also true for no chemical reactions. So this is our first equation, which is the ideal gas equation, and probably you are very acquainted with that.